Hi, welcome to the WebGL debugging screencast. In this screencast, I'm going to go through the basics of debugging your WebGL applications. To get started, I have here the Khronos WebGL wiki page about debugging. This is a nice source of links. It links you to WebGL Inspector, which is a nice tool for WebGL debugging. It's also got a link to the WebGL debug script, which is a little piece of JavaScript that gives you tools to debug your WebGL applications. In particular, it's got a WebGL debug context, which is a special wrapper for a WebGL context that makes all GL errors show up in the JavaScript console. So you can also customize it to do JavaScript style error handling, so that instead of getting back an error number, you can make it actually throw an exception when you get an error on a GL call. And what the debug context does is, after each call to GL, it calls gl.getError to get the error code. This is it causes a performance penalty if you use it in your production code, but for debugging it's great. It also has this little function, WebGL debugutils.glenum to string, which lets you take one of those cryptic error codes and get the name for the error. Very useful. Next, I'm going to show you the WebGL Inspector. So the WebGL Inspector is a little Chrome extension by Ben Vanik, and it's probably easier to show you what it does. So it's on GitHub, benvanik.github.com/webgl-inspector. I'm going to show you a live demo of the WebGL Inspector. So here we have a WebGL demo running on the screen, and clicking on the UI button, we get the WebGL Inspector. And now I'm going to go through some of the easy features. So Programs tab, you've got the shaders and the GL programs, and these have the uniforms, the attributes, the shader sources, the status of the shaders. So if you've got problems with your shaders, you can see it here. Then there's a buffers pane, which shows you all the buffers used in your WebGL program. Here you can see what is inside a buffer, what is the size of the buffer, and what has been done to the buffer recently. If we look at, I think it's this one, yeah, we have a 89K buffer, and here is a 600K buffer, and with these you don't see the buffer contents directly, but you have to click on this link to show them, which I'm not going to click because I think it's going to crash the browser if I do that. And I'll do that anyway. Let's see what happens. Yeah. Okay. Well, that was surprisingly fast. So 89K buffer, perfectly okay, no problem. You also have a textures pane that shows you all the textures in your WebGL application, texture settings, and what has been done to the texture. And in the textures pane, you can see all the textures in your WebGL program, and you can see the texture parameters for each texture and the texture contents, because this is a texture that was passed as a null texture, it is a GPU side texture that the WebGL program is editing on the GPU. We don't see anything in the texture contents. This is one problem with WebGL Inspector at the moment, which I think could be fixed. But if you have a normal texture, you should see the contents of the texture a-okay. In the state panel, you get a state snapshot of the current WebGL context state. It's got all the blending and the blend colors, color values, maximum attributes, and such like. In the timeline pane, you can see what's happening in your WebGL program. The timeline view shows you what you are doing with WebGL. So it shows you how much time it takes per frame to render your WebGL scene. It shows you how many textures you're allocating, how many programs you're using, and so on. Now, if we go to the trace panel, this is the first panel, but I'm taking it last. So the trace panel is the last panel I'm going to go to. And when I click on the capture button, what I get here is what happened during this frame. Here's the image that was drawn, and then all the GL calls we did to draw that frame. Very useful, very nice. Let's move on. So for unit testing GL, the Maps GL team here at Google built this little thing, GLSL-unit, which is a unit testing framework for GLSL code in WebGL. And unit testing frameworks that allows you to write and run unit tests for your WebGL GLSL code. GLSL unit will run your test code on the graphics card and extract the results, so it'll be identical to the execution environment of your shader code in production, and that is the great thing about GLSL units. If you want to hear more about GLSL units and how the Maps team was developing WebGL, you can go to this YouTube talk from GTAC 2011. It's Developing and Testing WebGL. It's by Roy Williams, one of the MapsGL engineers, and this is from the GTAC, stands for Google Test Automation Conference. And this is a great talk for real-life WebGL use in a non-game setting. So go there and check it out. This is about all I have to say about WebGL debugging for now. So thanks for watching, and get hacking!